Identifying Bronsted-Lowry acids and bases. So a Bronsted-Lowry acid is a proton donor. So you're looking for something which between the reactant side and the product side loses a proton. And remember, a proton is an H plus ion, so it's losing both a hydrogen and a positive charge. And a Bronsted-Lowry base is a proton acceptor, okay? So that means you're looking between the reactants and product side of something that gains a hydrogen and a +1 charge, okay? So we're looking for something to lose an H plus, and something that's going to gain an H plus between the reactants and product side. Okay, so the highlighted reactant in this case is the nitrate anion. So let's look at what happens between the reactants and product side for Mr. Nitrate. So we can see on the right hand side that we have nitric acid. So if we imagine we add a hydrogen atom to the NO3 minus, we get HNO3 minus, and if we add a +1 charge to HNO3 minus, we'll get HNO3 no charge. So that would appear to be accepting a proton, right? So that would make it a Bronsted-Lowry base. Okay, so we can see that it has accepted a proton. Okay. All right, so what about the nitric acid, the HNO3 in my second equation? Well, the relationship between the HNO3 and one of the product is the nitrate anion. And we can see that the relationship between these two is the nitric acid has lost a hydrogen, and it's also got a -1 charge now. So that would be equivalent to losing an H plus ion, so our nitric acid must be a Bronsted-Lowry acid. All right, so let's look at the second group then. So water is our highlighted substance. And we can see on the right-hand side, we have the hydroxide anion. What's the relationship between water and the hydroxide anion? Well, I see one less hydrogen and a -1 charge, so that must have lost an H plus. It loses H plus. We can see that relationship between water and hydroxide is just the difference of an H plus. So that must be water is a Bronsted-Lowry acid in this equation. And then lastly, we're asked about this hydroxide ion down here and the relationship with that, and I guess that's the water on the right hand side. So what has happened between the reactant side and the product side? It has accepted an H plus. So the difference in the formula is the addition of one H plus ion. So if it's accepting an H plus, that makes it a Bronsted-Lowry base. And that is all you need to do for those kind of problems. Yeah, putting ticks everywhere.